Hi everyone. So in this lecture we will be talking about quicksort, which is again a very popular sorting algorithm. So let's see how quicksort works. So we will discuss the concept and the implementation of quicksort to sort a given array or a vector. So a quicksort is a divide and conquer algorithm. Okay. So what we'll see, given an input array which is unsorted, it will help us to sort this array, and its average case time complexity is order of n log n, and in the worst case it can take up to order n square time. But yeah, it's one of the very popular sorting algorithms you must learn, right? So let's see how this algorithm works. Okay, so one thing to remember about this is it's a divide and conquer algorithm. Okay, similar to merge sort. What this algorithm does, in the first step it chooses a pivot. Okay, so you have to choose a pivot point. Okay, so a pivot point is a point about which you're going to divide your array. Okay, let's say this can be either the first element, or it can be the last element, or it can be any random element in the array. So for our example, we are just going to pick last element of the array as a pivot always. Okay, so whatever the array is given to us, we will pick the last element as a pivot element. Okay, the next step is a partition step. It's the most important part of the quicksort. So what, in this step, what you do, you try to partition your array into two parts. Okay, so what you will do, you will make okay, you will say, okay, I have a 4. I will put all the elements which are less than 4 in one part, and all the elements which are greater than 4 in another part, and 4 will be in the correct position. Okay, 4 will be in the correct position. So if I just see what elements are less than 4 in this array, so we have the elements 2 and 0. These are less than 4, and all other elements 5, 10, 7 and 6, 5, 10, 7 and 6, they are greater than 4. So we will put all of them in another part. So we'll see how to write this method. Okay, so once you have this, you recursively sort the left and the right part. Okay, you have to recursively sort the left part of the array. This is the left part, and this is the right part. Okay, so the two partitions that you have created, you can recursively sort them. Okay, so recursively sort, by I mean you again call the quicksort method to sort all of these elements. So if you sort these two parts recursively, what you will get, you will get 0 2 in the left part, then you will have 4 in the right part, and you also sort the right part, you will get 5, 6, 7 and 10. So this is how you can see you will get a sorted array. Now let me explain this partition method in more detail before we dive into the implementation. So these are the three important steps of quicksort, right? And since we are going to use recursion to implement this algorithm, you can also have a base case. If your array contains only 1 or a 0 elements, so you can simply return. If you have 1 or 0 elements, you can return from that part. Okay, so that will form your base case if you're using recursion, right? So let's see how this algorithm is going to work on this particular example. So in the beginning I will say, okay, let me keep 4 as a pivot element. So let's say this is pivot element, and now I'm going to explain you how you will partition your array. Okay, how to partition your array into two parts. So there can be multiple ways to write the partition algorithm. So there is a popular way to write this algorithm. It is also mentioned in the CLRS book, that is a very popular book for algorithms. So I'm just going to refer that method, and I'm going to explain you how it works, right? So the idea here is you have to divide this part into two parts. Okay, you have to divide this unsorted array into two parts. Maybe let me say this is one part, this is, let's say, unsorted part. Sorry, this is yeah, the entire part will be unsorted, but let us say we are dividing into two parts. The first part contains all the elements which are less, and the next part contains all the elements which are greater than pivot. Okay, so we all these comparisons we are making with comparison to the pivot element. Okay, that in case is 4, right? So what we will do, I'll say, okay, in the beginning I have I will keep a pointer here. Okay, I will say, okay, So I will denote the end of the part, end of the first part, and j will denote the element that we are currently processing. Okay, so it will be one larger than this particular index. Okay, whatever index is this, j would be one larger than it. Okay, so in the beginning I is at, let's say, -1 and j is at 0. So what we will do, we will compare, we will iterate from left to right, and we will compare whether 10 is smaller than 4 or it is greater than 4. So what we came to know that 10 is greater than 4. So what we will do, we will say, okay, I will not move, but j will move. Okay, so we have processed 10, so j comes here. So we come to 5. Is 5 greater than 4? Yes. So we will not do anything, we will just move our j pointer to the next location. So j is now standing at 2. Is 2 greater than 4? The answer is no. Okay, so if it is not, what we will do, we will expand this window. Okay, so we are creating two types of windows or partitions, you can say. We will try to expand this window. Now you may ask, how do we add 2 in this window, right? So answer is very simple. You basically swap 2 with the I plus 1th index. Okay, so or you can say I will come to this index now, and we can do the swap operation. So after swapping, you will get something like this. You will have 2, 5 and 10. Okay, and I is pointing at this index and j is pointing at this index. Okay, so at this particular index now you have a 0, so which is again smaller than 4, right? So you again do the same step. You say, okay, I will do I plus plus, and then I will swap these two elements. Okay, so I comes here and you do the swapping operation. Okay, so it will become something like this. You will have 2 followed by 0 followed by 10 followed by 5. So basically we are trying to swap these two elements. Okay, and now j is at this particular index, and here you have this element 7, which is greater. You don't do anything. Okay, so this is your first partition and this is your second partition, and then j is at 6, which is again greater than 4. You don't do anything, and finally we are finished. Okay, so this is the final state of the array after calling the partition function. Okay, so let me just draw it again. So it will look something like this: 2 0 10 5 7 6. Okay, so all of these elements, as I said, these elements are greater and these elements are smaller than the pivot element, and here we have this pivot element 4. So we have one more step in the pivot function. We have to do a final swapping. So let's say this index is now I and this index is j, and this index is the pivot index, which was the last element of our array. So we can simply say you just swap array of I plus 1 with the array of pivot. Okay, so this will actually place the pivot element in its correct position. So we will place pivot element in the correct position. Okay, so what will happen, 4 will come here and 10 will go here. So let me just draw this array now. It will become 2 0 4, and we will have 5 7 6 and 10. So this is how the array will look like after the first partition function call. Next time what you need to do, you need to call quicksort on this part of the array, and you need to call quicksort on this part of the array. So how it will work, it will say, okay, let me take 0 as the pivot element and let me try to partition this part of the array. So here we have only one element which is greater than 0. So 0 will come in its correct index and 2 will come here. So you will get 0 comma 2 by making a recursive call on this part, and you will also have a 4 here, and you will also make a recursive call on this part of the array. You will say 10 is a pivot, and this will become the smaller part of the array. And how it will work, all the elements are smaller, so you will have 10 in its correct place, and you will make a quick sort on left part of array. Okay, so left part is 5 7 6. You will say, okay, let me take 6 as a pivot and do the work again. So you don't have what you will have if you just make a recursive call on this part of the array. Okay, so how it will work, it will take 6 as the pivot, and then you will try to partition. It will become 5 6 and 7. Okay, and you will have a 10 here, and you will have a 4 here, and 0 and 2 here, right? So by making recursive calls, okay, by dividing the problem further and further, we can actually sort this array, something similar to merge sort. So I hope you really understood the quicksort algorithm, and in the next video we will discuss the implementation.